is close. He's like, oh, look, it looks the same. Bless you. Bless you, bless you. Does anybody else have another reason, though, as to why they're the same? No, what are you thinking, Tyler? What are you thinking? Perfect. Yeah. Did you guys hear what she said? If you solve for cosine A. Because doesn't this have a cosine A also? How would you solve for cosine A? Now, she started to like second guess herself, and I know why. Because she started doing it in her head, I think, and you were like, it's a little different. Pause. What if we did? Just real quick, is it frozen? No, it's not. What if we did solve for cosine A? Just taking this one right quick down here. Wouldn't it be a squared minus b squared minus c squared over negative 2bc? Can anybody do all of that mental math in their head? You guys tracking with what I just did? I subtracted b squared over, subtracted c squared over, and then once those were gone, isn't this multiplication? Yeah. So I had to divide. Oh, so close and yet. Wait, what can I do if the signs are opposite? Not add, but you're right. What's Joe thinking? Times. What if you multiply? I put the times in the wrong spot. Okay, there you go. What if you multiply top and bottom by a -1? What happens to all the signs? That's a negative, that's a positive, that's a positive. So I could rewrite it, the positive ones first and then the negative one. And what's a negative times a negative? A positive. Was Tyler right? Did you just need to solve for cosine? Yeah? So here's the real question. Do you technically memorize all 6?
No.
It's up to you. That's an open-ended question with no perfectly right answer. It depends on your brain. If your brain is like, no, all I need is this one, I can get that one, no big deal. Okay, then you just need to memorize 1, and I bet you get those 3 and that one and those 3. But some of you are like, no, that was a lot of math. I think I better memorize this one and that one. But do I think you need to memorize 6? I hope not. I hope we can just memorize 2 and then follow the pattern. So what's the pattern of law of cosines? Side squared equals the other 2 side squareds added together minus 2 times the other 2 sides cosine of A. Do you guys see the bookend? Do you see it? Little a and big A. But over here it's a little bit trickier because over here it's cosine of A equals b squared plus c squared, just like this one starts off, except like some of you guys were noticing and Matthew was noticing, you can't go the same direction because this got divided. B squared plus c squared minus a squared, there's your bookend. It's just awkward, all over 2bc. To be honest, I think at least half of you should probably memorize a standard form, at least one, and an alternate form, at least one. And that's nothing to like your discredit at all. That's just how your brain works. So I think probably at least half to 3/4 to maybe like 90% of us should memorize one of each. And that's not a bad thing. But I did just want to show you, these aren't like totally unrelated. They're super related because technically that one comes out of that one. But do you need to memorize how? No, it's totally optional, totally up to you. I'm going to leave it in the notes, but it's not a huge deal. Anyway, long story short, we need to learn how to use the law of cosines today, but we've had the formulas, or at least you've gotten time to put them in your notes if you didn't get them yesterday. We still haven't graded section 6.1 law of sines. So let's time out real quick. Throw your pencil in your notes. We'll be back there just before you can, well, I'm not sure. This might take a little bit of time, but let's go ahead and grade 6.1, huh? You guys can already see number 10. Let me scroll down so you can see number 30. You guys have a lot of checking, but theoretically, if you got like the first missing angle or side right, hopefully you got the rest of them right too. Just, lost my mic. So in number 10, the first 3 pieces they already gave to you. You could have found angle B just by subtracting from 180. Got him. Solve for side A using law of sines. Solve for side B using law of sines. They were doing 2 decimal places, kind of like, I think they gave that in directions, didn't they? Number 30. Ooh, number 30 was hard. Or was it? Did you guys try to solve and got an error in your calculator? Nice. That was perfect. Just say not possible. Matthew's up here being like, well, I was able to compare and see it was too short. Perfect. That's also true. Yeah, the opposite side was, little a was too short. There's no way he could have connected. The shortest distance between side B and side C was 10.86. Poor little guy was way too short. But the nice thing is your calculator. I know, right? It's crazy. Did you guys hear the little middle schoolers like screaming right when they got out of chapel? I was like, what? To me, like lockdown drills. I was like, what's going on? And then I heard the thunder, and I was like, oh, okay. We're good. It's just God talking. All right, so number 44. I don't know. There was this one time in high school. It was our spiritual emphasis week. We were outside under a tent. It's just ironic because it's your guys' spiritual week, and it's thundering today. It was like a big old white tent, and we were a small school. We all fit under a tent. Anyway, and all of a sudden, like, he was preaching, and then, like, it was pouring, and, like, the thunder started coming, and then, like, this tree in the distance got, like, it literally got hit by lightning. We were just like, ah! He's like, the power of God. I mean, it was cool. Like, he was doing it in an encouraging way, but we're like, oh, my word, the world's ending. But it was in a cool way, though. He was like, God loves you, and he is so powerful, and it was like, ah! Anyway, it just flashed back. Thunder. That's why I said it's God talking to us. Number 44. You guys just had to plug into the area formula. Wait, is this like the end of homework? Are there any more evens? Okay, there are a few more. Did you guys not have that one? Oh, 52 is extra credit. You guys need those two, though, right? Hold on. I must have just gone in order. Sorry, Lo siento. 56. Was he a nasty one where you didn't actually, like, find a number? You were trying to, like, make a table-y thing? I think I might actually just help on that one. Is that okay? Let's just check 62. 62 might be hard also. Did you guys have any questions before the last 2 evens? Let's go. Let's start there. The last 2 evens were kind of nasty and concept-y. Matthew, 51. Anything else before 51 that you guys might have a question on? Don't worry. We'll come back to 56 and 62. If you want, I can freeze the screen for a second while I get 51 on 62. This has to do with like too short, not too short, too long. Yeah. Let's start in 35, and then Matthew, remind me. Let me know if I forget what number you want. Here we go. 35. Anything else besides 35 before 51? Let me know if you find something. Number 35. Ooh, thanks, Priscilla. That one's hard. Number 35 is actually a lot like number 62. So you guys are looking at 62 right now, right? And they're asking you basically, double check me if I'm right, but I bet I am. They're asking how many ways or what the other side would be to make only 1 triangle, 2 triangles, and no triangles. Am I right? Okay. Peek at 62. It's actually easier than 35. Peek at 62. Let's talk about this really quickly. As you guys were looking at your points, you were trying to think about making a triangle, right? And yesterday you saw when I was swinging my little ruler that some sides were too short. Some sides were long enough, but not too long, and they could swing out and in. And then some sides were too long, and they only could swing out. What's going on in number 62? And actually, I don't remember what those 2 points are for. Did they just give you 2 points, or did they give you like a picture? Did they give you a picture? Oh, of course, the page that has 62 doesn't work in my book. That's fun. Okay. Go team. Matthew, do you have it written right there? Can I peek at it real fast? Yeah, the given information?
Yeah, it gives you a triangle.
Oh, it gives you a triangle. Perfect. Okay. So when you're doing your triangle, that's not going to be. Do you guys know who wrote that? Nobody knows who's that talented in their class? Yeah. Yeah. Kathleen Wayne. Okay. I know, I wish I could too. So Matthew, they gave you, I think, the 0.00, right? And then the 0.43? Okay. Guys, what's the shortest distance between 2 points? Straight line. So if you had gone ahead and labeled this triangle, you would have had 3, and then this one would have been 5 if this guy had been straight down 4. Oh, I switched him, didn't I? This guy's 4. Lo siento. This guy's 3. So a 3, 4, 5 triangle is one way. So if this opposite side was 3, it'd be a right triangle. That's why A equals 3 is in the top option, because a right triangle, well, if you were to swing this little 3 any way, he'd be too short. So the only way he can go is straight down. So A equals 3 is one way to have one triangle. But what if A was 3.1 or 4 or 4.1? Wouldn't it be too long?
No.
Well, it's too long to go straight down though, right? So how would you make a triangle if it was just a little bit longer? You could swing out. You guys agree? Or you could swing in. So that's why if A is in between 3 and 5, as long as A is less than 5, it won't backtrack past the 5. So if A is in between 3 and 5, if A is 3, he goes straight down. If A is something bigger than 3, but less than 5, he would swing out and swing in. And so the only other option is if A is bigger than 5. So if A was something like 10 or 13 or 25, if A was something bigger than 5, the only way he can go is out. He can't swing back in, or else you're going to lose your triangle. You're going to lose your triangle. That's what's going on in 62. So let's go look at 35, the question that Priscilla brought up, because it's super, super similar in that they only give you 2 pieces of information. Let me unfreeze the screen. They only give you 2 pieces of information and say, okay, so when are you going to get 1, when are you going to get 2, and when are you going to get none? Well, I'm going to do the exact same thing you guys just saw me do over there. I'm going to go ahead and approximate 36. No protractor for me today. Approximate 36. I don't know how long that side is. I'm just going to draw a line. There's my 36 degrees. They told me side A is 5. Oh, side A is 5. I don't know who this guy is. That's kind of annoying. Okay, let's say side A, just like that one, came straight down. If he came straight down, guys, could I solve for the unknown with sine opposite over hypotenuse? Okay, so sine of 36 would equal 5 over my unknown. X would end up equaling 5 over sine of 36 if you guys move it all around. Matthew, did you figure out what the right triangle would have been on 35? I'm just asking Matthew because he was doing a lot of the heights and altitudes yesterday. It's okay, I can plug in. Let's see, what would that be? 5 over sine of 36? 8.5-ish, 8.51. Okay, so I have my 1 solution, my 2 solutions, and then my no solutions. If A equals, nope, we're doing side B, sorry. If B equals 8.5, that would be a right triangle, just like number 62. So that's one way. But what else could make just one triangle? If he's too long. I could have him be just one triangle if he's a right triangle, or I could have him just be one triangle if he was too long. Now hold on. What would it be if he was too long? He would have to be bigger than him, right? Because I need a longer side to swing out and not be able to swing back. So, okay, if B was 8.5, that'd be a right triangle, so only one possible way to connect it all. But if B was shorter than 5, then 5 would be too long to swing back, actually. B was shorter than 5. That would only be one possible triangle. 5 would be too long to swing back. Okay, another way. 2 triangles. Well, if B is less than 5 to make only one triangle, it's kind of backwards since we're solving for the other side. What if this guy was shorter than him, but not too short? What if this guy was shorter than him, but not too short? What do I mean by too short? If B is bigger than 8.5, then this is going to be extended and he's going to swing. He's going to be too short. if B was longer than 8.5. Poor little 5 would dangle and you wouldn't make a triangle. So that's going to be the none. And then the other case, well, what haven't I talked about yet? Talked about lower than 5 and bigger than 8.5. I haven't talked about in between. Because number 35 and number 62 are super concepty. And it requires you to visualize. And what did I say yesterday? What did I teach you yesterday so you wouldn't have to visualize? How to use law of sines in the calculator. So, am I going to test you on visualizing on the test? No. I'm not going to test you on visualizing. So don't stress too much about 35 and 62. It made you kind of work with the visualization of when sides are too short or too long or in between. But don't worry, that wasn't the main idea of 6-1. The main idea of 6-1 is, can you do law of sines, solving for missing sides, missing angles, and if it's an ambiguous case, do you know to watch out? 51, right, Matthew, was the other one? Sadly on the other page, that doesn't show up in my poor little file that is somewhat corrupted. Anyway, let me go see. What are the directions to 51, Matthew? Do you remember?
Find the bearing from one location to another.
Peek really quickly, because someone said 51 with a question mark in their voice. Oh yeah, you guys did at 51. Okay. Oh, it's the plain one, right? Okay. Does anybody else have a question on 51? Can I see hands real quick? Okay. You guys had it in your homework though, right? Okay. 51 gave you a picture. From Canton to here, and then something about that was north, and here's your plane. And they told you this is 44 degrees. And this is 500 kilometers. And this is 720 kilometers. What are they asking for? Elgin to Canton. Okay. This one was hard just because, Matthew, we didn't really cover bearings super well or in tons of depth back when we were doing trigonometry. I kind of let you guys skip it. So let me just show you what they were actually asking for, okay? When they said to find the bearing from Elgin, which is this guy, to, was it Canton? Is that where you're going? What it's asking for, which is kind of weird, but it's asking, starting from north, it's asking this big old angle theta. That's what it wants you to find. Which is weird, because it is the angle in the triangle. But it's that plus the angle on the outside. Because bearings start from 90 and then come all the way around, which is a little bit messy and a little bit yucky. They did give you this one is 44, so we could say, oh, hey, 90 degrees, we can find that guy, which would be 46 degrees. So we actually have an angle side, which is why it's law of sines. We do need to find that little triangle angle to get the bearing. At the end of the day, I'm actually going to use something to do with parallel lines, because if you have parallel lines and a transversal, and if this guy is 44, like I see, yeah, this one's going to be 136, because they need to add up to 180. No, because sadly it's not parallel lines anymore. This is a totally different angle. Does that make sense? So I'm going to go ahead and use 500, and I'm going to use my 720 with law of sines in order to solve. So I could use sine of 46 all over, who's he across from? 720. Sine of my unknown x angle all over 500. And so we would do sine inverse to find x of, there we go. And then all you need to do is add that to your 136 and you have your bearing. Bearing is a special way of measuring an angle that starts from north and turns all the way around. It has to go back to like when you can say like pirates were roaming the open seas kind of thing. And if they were doing navigation, like if you're looking at the water, where's east and west and south and north? North Star. I know north. So theoretically, you could navigate from north always, even if you can't necessarily have a landmark for east and south and west. Does that kind of make sense? So that's where bearing kind of comes from. Once you have a compass, now you can see everything, and so it changes a little bit. But original bearing, North Star. Sine inverse of, do you have what the answer should be, Matthew? You have it, Salma? I think this one is, let me finish, 29.9. Yeah, and then you have to add that to the original. So you add it plus 136. Does that look right, Salma? Something? 7. That should be your bearing for number 51. That's final answer for 51 if you guys were wondering about that one too. What was the other one that was gross? Number 56, the Leaning Tower of Pisa. Yeah. It was a little bit scary. Not impossible though, but scary. Okay, keep an eye on the clock for me. I'm only allowed to spend 4 minutes on this problem. I could just show you the answer key and say, hey guys, copy, but that's exactly what you're not supposed to be doing in math, right? So let me try to help it out. If you guys have gotten stuck on 56, it's okay. Work it out with me. I'll show you the important information, okay? Here we go. 56, Leaning Tower of Pisa. You have a little guy who's off, true? And you have that, and then you have that. And then did they do the little right triangle this way? Is that what they did? Right? It was kind of like upside down and awkward. Okay, cool. They're saying the tower is 50, help me out guys, 58.3? Uh-oh. Okay. 53.6. Oh, there. Oh my goodness, there are too many numbers. Okay, 58.36 meters. Then we have 5.45, and then we have a little alpha, a little a. We have a little d. We have a beta in here somewhere, but I forget who's beta. Who's beta? He's my angle. Ugh. 5.45 in beta. Okay. I don't know if you guys saw who beta was. Beta's that little guy right there. Huh. Okay, what's going on? Find the angle of lean, alpha, of the tower. I think I see a little bit of a triangle where I have an opposite. I have a hypotenuse. I think I can use sine. Because alpha across from him, hypotenuse of him is 58.36. So we can find alpha by doing a sine inverse you do. And sine inverse of that guy would end up being 5.45 divided by 58.36. 5.358. Oh, sorry, you guys only do 2 decimals, huh? 0.36. Is that right? Find the angle of lean. I have my opposite. I had my hypotenuse. Okay, good. Letter B says write beta as a function of d and theta. Well, who's beta? Oh, he's that awkward guy. I see him in this bigger triangle, and this bigger triangle has, oh. Hey guys, can't I say that sine of beta over d is equal to, can't I do log cosines with an angle and a side and an angle and a side? I think so, right? Because they told me write beta with all these other guys, and I'm like, okay, well, he's in this oblique triangle. I have him and him and him and him. Hey, yeah. Sine of angle over side, sine of angle over side. And the reason I did that is because I can solve for beta by multiplying by d and doing sine inverse to both sides. I know it's awkward, but guess what? There we go. The work that you guys did a lot in your homework with SSA, they were just asking you to say, okay, what if you didn't know the numbers? Could you still write it out as an equation? Well, there he is. And then letter C says, okay, now take that. Oh, I just did letter C, didn't I? Well, there you go. Use law of sines to write an equation for the length. Oh, no, no, no. Letter C says get D alone. Okay, I could get D alone. Oh, it's a little awkward, though. I think to get D alone, I would put D on top instead. Remember how if we're missing a side, we put him on top? Ooh, I just passed my time limit. It's okay, I'm right here. D is equal to sine of beta times 58.36 all over sine of theta. But they said I'm only allowed to have a theta, not a beta. You guys know how you could get rid of beta? How do I get rid of beta? Hey, is this 90 degrees? Tricky little picture. They didn't show me that was 90. What does that mean? What's theta plus 90 plus alpha plus beta? What are the angles of the triangle supposed to add up to? You know what's tricky is you can actually subtract 90, subtract 90. Little stinkers. You can solve in order to get rid of him. Where is he? There he is. Because I know who alpha is too, so I could actually have kept going. I could actually plug in and I would end up with 90 minus theta minus 5.36. And that would have plugged in for beta, and I would finally have the equation that they wanted me to. Which I know is a little bit nasty, but it is right. 58.36 all times sine of 84 point, what's 90 minus 5.36? 84.64 minus theta all over sine of theta. Now I'm going to go ahead and pause because I've been doing a lot of mental math. And let's compare to see what they did. They went ahead and got the alpha just like we got. They went ahead and did law of sines for letter B, like we did, sine inverse of the blah. For letter C, they went ahead and, yep, 58.36 times sine of 84.64 minus theta over sine theta. They had to plug in all sorts of stuff to the law of sines. The only thing we're missing is letter D, and letter D says once you have this nasty equation, just plug in your table and go to 10, go to 20, go to 30. You're going to plug this into your Y1, plug in 10, plug in 20, plug in 30, just to see some options for what's going on. All right, that was messy, that was nasty. Let's go to law of cosines because he's a lot easier than the application-y problems to law of sines. Ugh, application problems, I know. Sometimes they get gross. So let's get to start all the way over again with new formulas. Wait, which formulas do you have to memorize from chapter 6? Do you remember? Just 6.1 and 6.2. And then no more memorizing of formulas, just trying to figure out how to do them. Welcome. Did you guys mind plugging into your calculator law of sines? That part. Did you mind it? Wasn't too bad, right? So law of cosines, guess what? Let's see if maybe, besides the word problems, it won't be that much harder. But pause. I kind of have law of cosines memorized. Kind of don't. Keep me honest as to plugging in, but you guys need to be looking in your notes because you don't have it memorized yet, right? What am I plugging into, cool kids, if I'm trying to find angle A first? Am I plugging into the left formulas or the right formulas? Well, find A is the direction. But which formulas? The ones on the left with little a squared equals, or the ones on the right with cosine A equals? Good. Cosine. Missing angle, we're going to do those formulas. Because then we can plug in, who's B squared? Well, who's B? 19. Let's square him. Who's C? 14. Let's square him. Minus, who's A? 8. Square him. All over 2 times B, 19 times C. What's so cool about Once you get the formula memorized, plugging in, what do you think we can do with our calculator? Punch in the whole thing all at once. Oh, but wait a minute. How do I get A alone? What do I do to both sides to get A all by himself? Yeah, cosine inverse. Thanks, Tyler. And the nice thing is, you guys might not have caught it at the end of yesterday, but I was like, hey, guess what? Remember how sine inverse, we were like, gotta watch out, check 180 minus? Cosine inverse does not have that problem because he's for different quadrants. Long story short, I just get to plug it in and be like, yep, I'm done, and it's right. And it's only one case, not two. So when I plug in, I'm able to go straight to my 22.08. 22.08. If you guys notice, I can just plug in the big old fraction all at once, yeah? One nice plug and chug. I probably would only say on the test, on a multiple choice, solve for one thing specifically, but a long answer could be solving the entire triangle. You could get the whole fraction. While you're doing it snazzily, you gotta put parentheses around the whole numerator that way. I'm double checking how you guys put it in, because if you know how to, Ariman, do you know how to do that? Yeah. If you know how to do a big old perfect fraction, then it won't get messed up. But if you're doing like a division sign, you have to put parentheses around. Joe, you got the parentheses, right? Numerator, denominator. How do I do this one?
Yeah.
Alpha. Oh, do your second cosine first. Alpha y equals C n over d. Enter. Anybody else need to know how to do the fraction? You guys know how to do the cool fraction? Okay. So, one nice plug and chug, and I won't mess it up, and it'll be okay. And my final answer is 22.0. Oh, no. Even though I wouldn't ask it on a multiple choice, Joe just asked me. The problem is saying you're not done, right? Now what? I have angle A. You guys tell me, who am I going for? Angle B? Sure. All right, cosine B. Nice thing is, though, we only have to do this one more time, right? So for cosine B, I have to use the other two sides, not B, but A and C. So A squared plus C squared minus the opposite side squared. So the orientation changes a little bit. Some of you guys might need to memorize it, and some of you guys can kind of figure out the pattern as you practice it in homework. But then all I have to do is, once again, cosine inverse of both sides to get B. Are we feeling the rhythm of what to do? So I would do my cosine inverse. I just have to rearrange all of my sides. 8 and 14 on the denominator. Instead of 8 squared, I would do 19 squared. Instead of 19 squared, I do 8 squared. But long story short, kiddo, isn't it just plugging and chugging? And then for C, all I have to do is go ahead and do 180 minus A minus B. I need you guys, when you do homework, I need you guys to make sure that you're able to do your calculator, okay? Come back tomorrow with questions if for any reason your calculator isn't working out as far as the plugging in. That's for side, side, side. Guess what? Law of cosine also works with side, angle, side. But can you guys tell me what you would be solving for? Do you know? Why do I know that? Because that's the angle that I have. When I go to plug in, I have A, I have C, and I have cosine of B. I can plug everybody in. But how am I going to solve for this guy? Square root both sides. And that's how I'll get to B. Now, I know you guys are packing up, but you're plugging into formulas. I think I can trust you to plug into this formula as soon as you realize, oh, okay, solving for the side B to go with the angle B. Square root both sides. Here's what I don't want you guys to leave. That's a word problem. It's okay. Take a picture of this page. Other area thingies are going to show up in homework. It's a minute off again. Some other area thingies are gonna, like area problems are gonna show up in homework. And if it's not side angle side, we don't want the formulas from last section. If it's side, 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 we don't want to have to deal with the geometry. A new formula is so much easier because this new formula says, give me A and B and C. I'll find you this new little guy S, plug in to your calculator, and you find the area without having to draw a picture or use geometry or parallel lines or all those weird relationships. So tonight, that's the whole section, minus that one little baby word problem. I think you guys can do it, but what do you need to make sure you have figured out? Calculator, plugging in carefully. I'm just waiting to the bell. If it doesn't ring in 10 seconds, I'll let you go either way. I think it's supposed to ring. We'll see. Take a picture of the page if you don't have it, though, guys, and come back tomorrow with any of the plug-in chugging that didn't work. Sound good? See ya. Oh, look at you guys. Jinx. Try to stay warm. Oh, is that what it is?
What's another one? But cool, sweet, makes sense, funny.
Bye, guys. We're having too much fun. Bye, Wesley. Bye, Joe. Got it all, Arlen? See you later.